think that should be working too. Now we've got YouTube. Okay, sent that. Okay, there we go. Now everything should be fully notified. Wait a second. Give it a minute or two for people to find it. I'm going to go and refill my water real quick. While I wait for a second, I'll be right back. Okay, let's got that, got water. Gonna set up the browser here real quick. Let's see if I can't get this to be a dark theme so that I'm not just every time I switch back and forth between the browser and the terminal, I flashbang everyone. Let me see here. Hope there's not too much background noise. I'm going to decrease the mic volume just to make sure we get background noise kind of filtered out a little bit. I know I'm talking kind of quiet. Okay, probably have to leave a comment. The final YouTube video, this is the first time I've streamed to YouTube. Here we go, move, we move tab. How do we do this? How do I do this? How do I move to new window? Move tab, there we go. Oh my gosh, I just can't see stuff. Okay. Let's see here. Don't want to have to do that. I might have to... Oh, I just have to suck it up. Suck the bandwidth. I should probably do this too. One last thing of setup. Okay. I guess at 5 minutes that'll be the hard deadline to start. That'll be the hard deadline. Okay. So let's see here. Yeah, just, okay. There we go. Alright. Officially starting. So where to begin? I think the thing about Nix is that people see NixOS, they see, you know, the Nix packages and people using all these functions to create derivations and such, and they get intimidated. Actually, let's go and let's get, oh, I forgot I have to set this up. Okay, well, I'll have to set that up later. Why does DuckDuckGo have trackers? I don't know. Let's just clone Nixpkgs here. So you can see what I'm talking about here. Here, why don't we do this? Get clone. There we go. Oh dear. Why is that not working? Git should be installed. So I don't know what's happening. Give me a second here. I just set up the alpha iguana. Oh dear. Oh right. I just set up the alpha iguana thing here a second ago, so I have to. Apparently, it's not properly configured here. Oh yeah, look at that. I messed that up big time. Somehow. Wait, no, I want to go back here. Sorry for the wasted time here. Okay, packages, that's what's happened. Okay, we're gonna rebuild real quick. Unforeseen. Hopefully there are not too many unforeseen difficulties here. Oh, I see what's happened. Okay. I see what's happened. It's fine. We can just here we go. I have to do a little bit more setup here. Here we go. Let's do this just in case. Just in casesies. Just gotta do this. Sorry about this. I hope to have everything set up so I wouldn't have to do this. This is kind of disappointing, to be honest. I might have to create a trimmed version of the video. There we go. Just clear that out real quick. I know nothing's changing on the screen right now. That's okay. Well, in a second, when I get this figured out on the other monitor, get patched up. It's a big garbage collect. Okay, yep. 43 gigs freed, my goodness. Now we should be able to clone it. Yes, we can. Perfect. That's perfect. later, sooner. I can't install Windows. I can't install Firefox. Uh, reading the chat here. I don't fully understand. You're trying to install Windows. Where are you? Where do you stuck on? I guess it's. I don't fully understand. I should probably. The latency is pretty bad on the chat on Twitch. Installing Firefox is stuck. Like, are you on what are you on NixOS? What's your distro? How are you trying to install it? I'm cloning Nixpkgs just so that it's easy to traverse it, so that we can look at stuff later. Oh, you're on Windows. Like, is it like you have the installer open and it's like just like some stage of the installer is stuck? Yeah, that sucks. No more of this. Don't understand. Windows can be a pain in the bum. My goodness, this is taking a while. I mean, it is. We're cloning at 20. I guess I don't know if like GitHub limits the download rate. It feels like it, because I feel like I should be able to go much higher than 20 megabytes per second. Maybe not. I don't know. I mean, it's megabytes, not maybe bits, not megabits, which I commonly see. It is, though. It looks like it's going to be nearly like 2.5 to 3 gigabytes. So that is a pretty big clone, I will say. I'm gonna have to, in the final YouTube video, I'm gonna have to include like a description element of like actual tutorial starts. Here, new pipe. It's new pipe. New pipe. Oh, interesting. Nice. Yeah, I mean, that doesn't surprise me. It's probably something that that YouTube did something, because they hate those things, like new pipe, like uBlock origin. I mean, they've been massively just losing the battle massively against uBlock origin. I know that because I've never experienced an ad on uBlock origin. Honestly, I don't really mind the YouTube ads. They're annoying, but I understand that, it's their business model, and you gotta, they're gonna, if you fight it, they're gonna do crazy crap. But I don't like the tracking, though. That's why I turn off uBlock, or that's why I have uBlock origin mainly, is to prevent the tracking on YouTube, because Google just you'll watch it, and just the number of blocked cookies just increases by the second, and just one, or it's like it starts off at like 60 and it goes 61, 62, 63, 64, 65, 66. It's ridiculous. Absolutely absurd. I'm not doing that. Yeah, but Windows is, I'm not, I don't like it. I use it as a sandbox for certain video games that have, you know, anti-cheats and stuff, where it's just like, I don't want that on my main, like the computer where I like do everything else. I want like a basically a sandbox for that. Um, yeah, that's sad though. New pipe, stuff like that. It's pretty cool. They hate it though. Okay, let's. Okay, so I think we've got that covered. But I'm not actually going to use. I may not actually use Nixpkgs this stream, at least not yet, because um, I want to start off with basically the Nix language, because a lot of people will see stuff like the Nixpkgs stuff and get really, really intimidated and think that NixOS is like super duper complicated, when it's not as complicated, I feel, as people think it is. And I think that, you know, that kind of extends to, there are so many parts of Nixpkgs that are, which is a huge thing, by the way. It's absolutely enormous and difficult to follow the source code, as we'll see. And when we get into Nixpkgs and the different things you do in it, I'm going to be guiding you through the source code of Nixpkgs, so that you can get used to that. Just ruined sound on my Debian by installing a bunch of Wine packages to play games. Oh god, Wine is just, it's so sad. I'm glad that Steam Proton exists. Wine needs to step up their game. Like, it's still useful for, like, ordinary apps, but, you know, thank God for Proton, honestly. I love Proton for, like, the, you know, the DRM list games that don't have the, yeah, just DRM list games, that are nice and don't have the, what I like to call the worthless clause, which is, you agree not to reverse engineer it. Like, who cares? Like, first of all, that's so stupid. Like, okay, if I share anything, like if I share an object dump, yes, is that, like, should that be a violation of, like, copyright stuff? Yes, probably. But if I'm not sharing it, what's the harm? Also, it's literally unenforceable. Like, it's actually unenforceable if I, you know, obj dump it. It's, or if I, you know, chuck it and, you know, copy the executable code and chuck it in Ghidra, no one's going to know. You know what I mean? Like, it's completely worthless and it's stupid. Just, why would you do that? Just, it's lawyers who don't know how technology work. It's just like Congress, you know. Just like the U.S. Congress, who don't, it's a bunch of boomers who sit around and don't understand anything, and yet they're legislating the hell out of technology that they don't have a clue about. Honestly, I should run for like a House or Senate position, just so I can be the technological person on there. If they're going to be regulating AI, they should at least know, they should at least have someone there to educate them on what that means. Would they listen? No. Especially like if I run as one party, then the other party is going to block everything that I propose, just on a matter of principle, probably. Anyways, back to the subject of what we're supposed to be talking about. Engineers versus people who are paid not to not understand. Basically, that's basically it. They're paid to, they get their power and money from basically, you know, saying and convincing the public, you know, they like to invent problems that they can solve. You know what I mean? I can, let's just say I can think of certain politicians who are really good at just making mountains out of molehills, so that they can be talking about an issue that no one else is talking about. You know what I mean? And often that centers around technology now. It feels like it's just, I'm worried about TikTok. I'm not a big fan of TikTok, but the reasons many Congress members have for banning TikTok are just, they're not the right ones. This is not the good reasons. There are reasons for restricting it and stuff. These are not them. Anyways, so people will look at so I think it's important to start with the Nix language first, and then ease into aspects of Nix packages. And along the way, I'll be showing how to find, where to find documentation, and stuff like that. So let's start with the language here, and I have here the language reference. This is the Nix manual. Note that there is a lot of stuff that you'll see people using that does not appear in here, because this is about Nix. It's not, and NixOS. It's not about Nixpkgs. Which we'll get to, but let's start with this here. So I'm just gonna also be kind of reading this so that I can kind of jog my memory about, like, where to start, what things there are to talk about. But I think that'll be helpful though, so you can see how I find documentation, where I go, that sort of stuff, because I think that's a massive part of tutorials. So let's start with a thing that you're really going to want to do, which is whether you're doing Nix on, say, on Mac OS, on Linux, on WSL, whatever, you're at least, like, I understand the people who are like, no, flakes bad. Like, okay, that's kind of a characterization, but you get what I mean. I understand the argument. Now, the thing though is that you definitely want the Nix command specifically for this. This is going to be an invaluable tool to learners of the Nix language, and also debuggers of kind of figuring out what's going on in Nix packages. I think we'll start off with Nix REPL, read, evaluate, print loop. If you didn't know what REPL stood for, I don't use Nix / NixOS. The lag is like the latency between, like, the chat messages. Like, I think there's like a latency between me, like what's happening on my end, what's happening on people's end who are watching the stream, and then the chat messages have maybe an even worse latency coming back to me. So I talk about stuff, and then like at least 10 seconds later I'll see a chat message about something specifically. Understand argument against flakes. There are a couple of reasons. Now, I see ways around them, but I think my main criticism, my main argument against them, I should be more mindful of lag. Yeah, it's a thing. The problem is that first of all, like, I forget, because there's like settings about latency, I don't know where they are, but also I think that they prioritize bandwidth and the latency stuff, like prioritize that stuff for larger streamers. So someone like me who is currently sitting at 16 followers on Twitch and 1 subscriber on YouTube, they don't care about YouTube, but my point is they're not going to give me their bandwidth. They're going to like give me the minimum of what works, and like the features that they promise. Yeah, but like Flakes, the main criticism I think is, first of all, like, unless you do a certain thing, cross-compiling is just, it doesn't exist. If you're trying to cross-compile a flake, generally, to my understanding, I don't fully know about flakes. That's something that I'm learning, but to my understanding, cross-compiling flakes is virtually impossible. Unless you like set it up a certain way, which larger projects should do anyways. I know that way, and I will teach it. But flakes are, I'm not a total Nix master yet. I just know enough about it where I feel confident in like the non-flakes area, teaching the basics of it, because I've been digging through the Nixpkgs source code a lot recently to figure stuff out, because I've been writing a derivation for a pretty complicated project, so I've really been having to dig into Nixpkgs, because the documentation is not great. It's exploded in how good it is, but it's not amazing. Still. Where did I leave off? Yeah, but flakes, it's pretty hard to, you can't, like, you can only define certain systems, and you can't really input, arguments into a flake. I think you can have a flake output, have it be like a compound, like a flake, but also have it act as a library, so you can import the flake, and then have like a function that does the derivation with arguments, I think. But I'm not, that involves yet another, doing the same thing, which is kind of having an external derivation with args, and doing it that way. Yes, the REPL. So we're going to be focusing on the Nix language for now in the REPL. And we're going to focus on just the language for now, then we'll get to .nix files. Because .nix files, I guess I'll just bring it up now, they're expressions. Basically, just whenever you import a file, and I'll show this, it's just imports, basically yanks the text of it and uses it as like a Nix expression, if I had, like, you'll often see them as, basically having the expression be a function, and I'll get into that and the different forms of functions and how that is a function, because I feel like a lot of people would look at that and scratch their head about kind of, that's a function? I don't know, what's going on there? I was at first. That was definitely me. So the Nix language is pretty simple. It's designed to be simple. The Nix language itself is designed to be incredibly basic. Like, for example, there's no switch statement. There's if and else, but there's no, like, switch. There's a way to get around that that's, you know it, by the way. Yeah, I mean, I'm not, again, I'm recording this to YouTube. This stream is being recorded. So that's the idea, is it's going to be kind of a tutorial, not to specific to specific people, but instead the start of a generic thing. Boo. Have to have matched. Yes, I agree. There is a way to do that. Oh, there might be some background noise soon. There is a way to do that, and I will show that is very common in Nixpkgs, and I think that's the intended way. Okay, yes, you understand the streaming thing. So these are, an incomplete overview of Nix features. There are different data types. Null is a thing in here. Any data type can be null. The data types are pretty simple, and the operations are pretty simple. We have strings, we have numbers. There's no distinction between ints and floats here. We have paths, which I'll get into. Those are kind of complicated. Those are a bit weird. Booleans, and of course null is its own type. Oh yeah, I forgot to mention, like, because it's not, because the language is like, variables are immutable, because it's a functional language, as we'll see, there's not, mutability is not a thing, but it is dynamically typed. So null is its own type, and, it's not the same as undefined. Undefined is something else, and we'll get to how to handle undefined as well, which isn't a value at all. But yeah, we have lists, and attribute sets, which are, lists are basically, they're like, dynamically typed arrays, or each element is dynamically typed. As you can see here, we have a number, we have a path, we have a string, we have a function. No, sorry, that's an expression that's calling f with this attribute set that has x equals y, and presumably y is something that's in scope up here, maybe. Yeah. So some things there's a lot of parentheses, and we'll get into kind of developing an intuition for where and when you need parentheses, hopefully in this stream and other streams. I won't go into the exact logic of it, although I'll try and describe what I understand of the exact logic of it. Attribute sets are pretty straightforward. They're enclosed in curly braces. Their identifier equals value ended with a semicolon. All of them, including the last one, are ended in a semicolon, always. A lot of things end with semicolons, interestingly, which is kind of in some weird places. There are reasons for that. The Nix, there's some weird stuff in this language. Like, for example, no commas in lists. I would not do that personally, because it leads to this. I'd like to have expressions not being closed in parentheses. So there are things that, yep, parentheses everywhere. Here you can have them, of course, because there is a terminator, which is the semicolon. For some reason, not a... Are there... I just realized, I don't think there are commas in... Are there commas? Am I being stupid right now? I'm racking my brain whether commas appear in Nix or not at all. No need for semicolons, parens, enough to group stuff. Yeah, basically. That is a thing. It's inconsistent between the list and the attribute set. That does annoy me. I'm just sort of scrolling through so we can get the basics and then we can flesh these ideas out, I guess. This is a very messy tutorial. The messiest tutorial ever, possibly. Possibly the worst. I don't like messy tutorials. Although then again, it's just sort of hanging out and talking about it, so I don't know. I need to stop going on tangents about like whatever politics or what the hell ever, though. So yes, we access attributes with the .a. There's another way to do it. There are a couple of other ways to do it, though. They're kind of tricky. You can access through a string, like a dynamic access, through a weird way that's kind of obscure and that isn't taught very readily early on, which I wish we will get into it, kind of the bash-like things, which are really weird, but I actually really appreciate it. I like it. Controversial take. We'll see. Obviously evaluates to... this is an important one. The or keyword. This is an important piece right here, where if an attribute you can use or if against an undefined value in an attribute set. If you have an attribute set access operation, you can have you can put or after it to provide a default if that attribute does not exist, which is really useful. There are a couple of different ways to do these sorts of things. So that's something to remember. That's not so obvious. You can use arbitrary double quoted strings as attribute names. Okay, yep, there we go. That's another thing that's not very obvious, as we'll see. Oh, they are going to show it here. Okay. Yes, string substitution. You can kind of gloss over this for now, and we'll get back to it. But there are a lot of things because, like, for example, operations are required, like, okay, that works, but, like, if we do this, wait, what? What is going on? Am I just being stupid right now? I know that this will be interesting. Unexpected ints. Did they change that? Oh, right, because, okay. I see what I'm doing, because I'm using numbers. But if we use, like, A equals 1, B equals 2, oops, B equals 2, then, A plus B, this might work, but this would not work, because they have, because in order to accommodate the widest possible, kind of, how would you say, like the widest possible different methods of naming things. They do a lot of stuff like, access, string-based attributes, string-based accesses, substitution like this, as we'll see. And this is an important thing that you have to add a space between. Will this work? I don't know. Okay, that works. But the A or something hyphen, it's not subtraction. This will go to an identifier. If you do a number, though, identifiers may not start with numbers unless they're enclosed like this. Then that works. Integers are not closed under subtraction. Are not closed. I don't fully understand. Okay, ignore. So, and you know, that's why we have this here. Attribute names support string interpolation. This is the syntax that I was referring to earlier. We'll get into string interpolation later. You can see here, this is actually how we do the switch, by the way. We'll see that. This is generally how a switch statement is performed, is that you have potential things, like basically it's an attribute, and we get at a certain variable, that's a string. We use this access to do a switch. Will simply not be added to the attribute set. I actually didn't know that. I haven't read this too close. We'll probably ignore this for now. But yes, this is part of string interpolation, where this is inside. This is a Nix expression that will evaluate to one of three different things. Okay. I've never seen this before, this used before. It's an interesting thing to know. So, recursive sets, yes. So you should avoid them if possible, by the way. This is kind of where variables come in. Is recursive sets is one way, which you should generally try and avoid if you can, in my opinion. To my understanding, they can be slower than, not always, but they can be slower than, for large attribute sets, they can be much slower than let expressions. But this is pretty self-explanatory. If you put the rec keyword before an attribute set like this, then that will be recursive, and attributes can reference other attributes as variables, even if, in arbitrary order, which is otherwise not possible. Like, for example, if I do this, A equals 1, 1, B equals A. Oh, probably because this is probably the other way around. Actually, by toying around with this, I'm actually learning a bit. Are these recursive by default? Huh. Equals A. Oh, right. Oh, I know what's happening, because A and B are defined. That's what's happening. So if I do this, though, like, like X and Y here, it's not, X, oh, right, because Y equals A. Oh, gosh. Yeah, there we go. I'm 90% sure this will happen the other way around. I'm just, oh man, I was having earlier setting up the stuff earlier because I'm just really not, my brain is not working very well today, apparently, and I like nearly bricked my computer like twice just before I started this stream. Trying to do stuff in sudo and not, like, I double check my command and I would not catch mistakes that would completely destroy my computer if I, like, that would make things difficult and possibly cause damage to the system. So let expressions are pretty self-explanatory. This is kind of how you have variables. You see this a lot. By the way, that's how you get out of the Nix. It's like Vim. How do I get out of the RIPL :Q? Because otherwise, Control C does not work on the Nix RIPL. It will cancel the evaluation of an expression or whatever, which is really useful. So that is safe to do. But in order to exit it, you will need to use :Q. So if you're going to use the Nix RIPL, that's something to put on a little sticky note or something. Like let's go to let's look at an extreme example here of let else, just for fun. Where is it? Oh dear, I forgot to copy over the, hold on, let me fix this real quick. Let me fix this real quick. Wait, what's going on here? Oh, right. You can hear the typing to know that I am doing something. I'm not just sitting around here. This should, no? Okay. Helix, okay. Oh, I see what's going on here. Wait, oh, did I mess this up here? I should just be able to. Oh dear. All right, great. See, I've been, it's not in the sudoers file, but I set that up though. Oh my. Okay, so I'm gonna have to fix this off stream. Okay, What's going on here? Oh, right. Bear with me here. Oh dear. There we go. Okay. Okay, there we go. Okay. That should work. There we go. My goodness, that was difficult. Okay, so as we can see here, this is what an extreme case of a let expression is. This is as you know, as we've seen here, this is a function called syntax. But this is an extreme case here where we have a let thing here. We're doing some inherits, which we'll see. Then we're just defining tons and tons of variables which are based on each other. And if you can have a variable can be a let bound variable can reference an earlier let bound variable. And as you can see, it's just this is what it looks like. We can just define a name equals similar to attribute sets here with the semicolon. So you can think of it as kind of like a weird attribute set sort of thing. You can see here we're defining make derivation extensible const is equal to a function which references, I believe, this references a further a later variable. So that's something you can do as well. I forgot to mention that. Because these are lazily evaluated, the expressions are not evaluated until they're used. And so that is pretty useful. So let, then the other end of let here, let algo in, and then we have an expression underneath it. So an expression, a Nix expression can be start with let and then have this kind of attribute set like sort of thing in, and then the expression that uses for that expression, these variables will be available to use. We use algo here. And we see here some string interpolation, which we'll see later. So that's that. So that's an example of that. Let expressions, inheriting attributes. This can be used within a let expression or within an attribute or an attribute set, is to inherit a variable from an inherit an identifier you can inherit an identifier from the available scope. So that can mean a let expression that you're in. That can be, you can have let expressions in let expressions, by the way. You can have, let binding equals let whatever in expression, semicolon in, right? That's something you can do as well. And the attributes, because it's of that lazy evaluation, the attributes of the outer let expression will be available to you in the inner let expression. If that makes any sense. If it doesn't, ignore it. We'll come back to it. So we can inherit to bring things into scope. We can also use another inherit syntax here, such as let x equals 1 in, here we go. In, now let's say this, it'll be an attribute set, and then we can inherit x, right? Oh, right. We have to have a semicolon after inheriting x. We also have to have a semicolon after the binding. So as you can see here, we've inherited x, but we can't do this, I don't think. Yeah, no, we can't do this. But we can do this. If y now equals another attribute set, we can do that. And we can just do this as well. I was just showing that there can be an expression in, you can have an expression in the parentheses here, as long as it evaluates to an attribute set, and then the identifiers that you put after it in the inherit will be attributes of that attribute set that you're inheriting. And this can be, these identifiers can be basically any identifier that evaluates to something in scope. This can be a let binding. This can be a function argument in a function. This can be anything when you're just doing this syntax or this syntax. Here, it's an expression. You're using an expression, and these identifiers are supposed to be the attributes inside. They're identifiers to the attributes inside the attribute set here. So that's what that is. I'm pretty sure, maybe I'm missing some nuance here, but to my understanding, that's how they work. So that's inheriting attributes. Very useful. We saw that earlier with a bunch of inherits, which make things very, very easy. We'll see another way to kind of inherit all effectively with width. But that will probably come up next. This fragment from here we go. Okay, so this is where it's very useful. You can see here we just inherit a bunch of just take a bunch of variables from somewhere else and just pull them into the attribute set, or pull them into the let binding to kind of redefine them. here we have an example of the expression in the parentheses, and we're pulling an attribute out of that. Yep. So it can cut down on stuff dramatically. And by the way, this is not just used to, I don't know if I made this clear. This is not just to pull, if it's in let binding, like it's not just pulling stuff into scope. You know, like with will pull things, everything from an attribute into set into scope, but it will not actually put those attributes into whatever you're building. It will not put them into a let binding, like actually redefine them in a let binding. It will not actually pull them into an attribute set. That is only to put them in scope, similar to a let binding. We'll see with, I keep mentioning with, we'll get to it, just hold on tight. So we have that. Yep, so we bring that in. This is one way to bring built-ins in. You can also do, if you're kind of cheesy, you can do with. With is considered a little bit bad taste. I mean, you can do it, but it's harder to statically analyze. So that's why it's just a little bit frowned upon. Just a little bit. Sometimes. But I mean, it's designed to not be that way, because you're still not, you're not like wildcard pulling into attributes. There's no wildcard inherit. So functions, this is a very important part. There's two general forms of functions. And functions are always something, colon. If you see a colon, it's pretty much guaranteed to be involving a function. There's two different syntaxes. One is where you just have a I mean, it's technically a syntax of a function. There's technically two, but there's kind of different ways to take multiple args. There's two ways to take multiple args, but normally you just have one arg, which can be of any type, and then so you have the arg here, and then you have the expression that the function evaluates to if it's passed. So let's do some examples here. So let's say this is, there we go. So we have +1 here. That is a function that takes an arg and returns arg +1. So we can see here the basic usage of them. You take a function and you can use that function in the scope. Now functions are called using this syntax, where you just take the function and you put space and then a value after that, and it can be an expression, but you're going to have to put it in parentheses, like that. So it's kind of, just put an expression after the function and that calls it. Now we can see here some tricky stuff here. So we have negate. This is just a basic function here. Here we have something known as function currying. This is the first way to take multiple arguments in kind of the syntax x plus y. So we should probably we should probably kind of break down what's happening here. Like this is essentially like this isn't magic. This is x is it takes an this is a function. Add is a function that takes an x and returns, what does it return? Another function. This is function currying. But that function can capture x. It can still capture x. And then also use our argument y. So now we can add 1, 2, and we get 3. So that's one thing. So that's kind of one way to take multiple arguments, is via function currying. Return a function that captures the old argument. But this can be a little bit tricky here, because we can redefine now +1 equals add 1. What just happened? Well, now we called add with 1. We only called it with one argument. So let's break down what happened. We put in x, and it returns y of x plus y. So now +1 is this function. We've called add already, but it's returned this y function, this y taking function that has captured x. Sorry, we've captured 1 here. So now if we +1, 2, it'll add 1 to it, because we've already captured 1 into the x, and now our function that takes y has already set x to 1. That's what function currying is. That's the so you have to be, I'm bringing this up not just to demonstrate what this is or why it is, but that you need to be careful when you see this, and especially when you see this. When you see a function that has this sort of thing going on, that's not called with the same number of arguments. It is not, what has happened here is now what has been returned is a partially completed function, or it's kind of, you could say it's like partially completed, right? You will call the function with the rest of the args when you call it again. That is that is the effect of function currying. But there's another way to take multiple args, which is pretty obvious, which is that you is that you just take an attribute set. Oh wait, here we go. Add equals. There we go. Now we can add 1 and what? Value is an integer while a set was expected. Oh right. I'm really foolish. Equals 1. Y equals 3. There we go. And we get 4. It's the idea is to take an attribute set and use the names. But there's a special syntax for this, which gives you a special ability with Nix functions that take attribute sets. Let's take a look. There we go. Bad at typing. So now we have the same thing, effectively, but it's sort of like in Rust, where you have argument expansion. You've kind of, you've taken an attribute set, and here we've kind of broken it down. And that will enforce, that's a great way to enforce that that you use an attribute set, and that you use the correct parameters. But also, not only does it give you this as a convenience, right? But it also gives you a special ability. And I'll show you that right now, which is to provide defaults to the values, which we can see here. Actually, let me test this here in a second. You might be able to do this with regular args, but we can define defaults. Y equals 2, and this will evaluate to 3 because we have a default. X defaults to 1. So if it's not defined in the attribute set that we pass in, then that argument will evaluate to the default. I think, let me test something here. You might be able to do this actually. Okay, yeah, no. You can't do it. Or, I wonder if you can or too. No. In any case, so my hypothesis is kind of validated though, that this is, that you, to my understanding, you need a default. I mean what am I thinking? Like, why, how would you do this? Like a default, like why would a default work here? Because in order to call the function, in order to make it clear that you're doing a function call, you need to pass something, otherwise it's just a function. Why am I being silly? Why is my brain not working today? I don't know. I genuinely don't know. So those are your function calls, and you'll see this a lot, which is kind of this multi-line where you have multiple args with defaults all in separate lines, and then the end of it, the last line of that will be this, and then after that you'll start with an expression, you know, if like that on the next line after this, which ends the arguments. So that's what's going on there, if you see that, which is just your, you know, the file is a Nix expression, and the Nix expression is a function that takes those args and returns, usually, if, you know, an evaluation of, packages dot pkgs dot mk derivation. That's the most common for derivations. That's the most common thing you'll see. So you'll see here, they're basically going to say that here. This is an example of calling them, concat. We have string concatenation with plus. We have if then, if conditions expression, then true expression, else false expression. We'll get into for. We'll dig into for in a minute. Here it has, so we see here the function currying. This is useful for, map. You can curry stuff like the map function or whatever, or fold, pass in one argument, and then have that be a function in of itself that can take something else. That's a great way to utility define functions. Set pattern. Oh yes, I forgot. No other attributes are allowed. If you want to allow additional arguments, you can use an ellipsis. So that will basically make it so normally these are nulled out. However, we'll see that there is a reason why you would want this, why the ellipsis is very, very useful. Which is that miscellaneous args, if you want to pass the rest of the args into the args that aren't used, that got passed into the attribute set that got passed the function, you can do this. Args at you know, or call this whatever you want. It's an identifier at, and you have your args, your attribute set, and you're obviously, you're probably going to, if you're doing this, you probably want the ellipsis. This basically allows you to use the attribute set instead of it being like just expanded. You can use, you can directly use the args passed in as an attribute set. It can also be written as, I see it written more like this more often than I see it like this. You can do it either way, so just be aware of that. If you see code, it works either way. Okay. In particular, args does not include any default values specified by that in the function set patterns. So that's another thing to be aware of. So conditionals, here we go. We're finally getting to if here. This section is a little bit iffy. So this is very brief. It doesn't really give any examples. But yes, E1 is an expression that evaluates to a Boolean. E2 is an expression that will be returned if E1 is true, else E3. I think now is a good time to really dig into that syntax that I was talking about earlier, the match syntax, which I'll just bring up here. We'll get to string interpolation, but I'll just show the syntax for convenience because it's relevant to this. So let's say we have our options here. O1 equals foo. Oops. O2 equals bar. O3 equals baz. Okay. And we have, so this will be our potential things. This is our kind of our switch statement where we define our options, define, you know, what will happen, the expression that will be evaluated if we, you know, and then we basically, you know, how do we get an attribute by a variable? Let's say we have x, that is our, or we can, you know, this is just our expression. You know, this is the expression that will be tested, and it must evaluate to one of these, O1, a string, you know, that is O1, O2, O3, and then the string will be checked against the identifier names in the attribute set, and we'll get that, you know, we'll evaluate whatever expression that thing is. Or not, we won't evaluate it, we'll get it, which is different than evaluation. It won't be evaluated because it's purely lazy, right? It's going to keep being lazy. You know, this is not necessarily going to evaluate it. We only evaluate it once it shows up, once it's being evaluated. The conglomerated expression of lazy expressions is brought up in the final expression of whatever it is. Then everything necessary will be evaluated. Assertions, these are pretty simple. These are just, these can be tagged on to before an expression, any expression. They just sort of get canceled out and won't really exist. You know, they won't affect the final expression that comes after the semicolon. So for example, we can say sum fn equals x assert x like that or something really, excuse me, something really stupid like that. You can see that it comes sort of like a let in expression. It's what could that stuff be used for? Are you referring to there's probably some lag on the chats, the YouTube chats. So could you be a little bit more specific? I'm going through the Nix language to kind of explain how to use Nix. That's the idea. So this is, but assertions are really good. They're pretty awesome because you can just evaluate an expression and assert that it's true or whatever before returning an expression. So that's pretty neat that they can just come in anywhere when it's about to be an expression. You can't just stick them in an attribute set though. Assert 1 equals 1. You can't do that. But you can do this. You know, it doesn't work like inherit. There we go. So that's an example. That's what that is for, assertions. And once we get to Nixpkgs, we'll look at how to send a message with an assertion and kind of assert with what is the Nix used for. I mean, you can Nix is the language that the Nix Nix is used for package, service, and project dependency management. Yep, pretty much. That's, I mean, I can pull up here the NixOS website here. You know, they kind of advertise their things. The main thing here is it's community driven. I say advertise, but no. You know, the Nix system is not just it's not just there's NixOS, which I use. It's a Linux distribution. They call it a Linux distribution, but it's not really. It's a Linux-based operating system is what I'd call it. 1 second. Hold on. Wait, no. Whoa. Okay, there we go. That was a bit of a mess. Okay, there we go. Let me check this, check that, check everything. So, but you know, you can install Nix on Linux, Mac OS, Windows via WSL2, Docker. It's a package management solution, but it does a lot more. And on NixOS, it is used for kind of defining the defining the system, so that, and it's really nice. I really like NixOS because, like, oh, this system configuration or whatever, you know, that's really cool. This other person is built, and I can just, like, you know, they just, oh, well, here's my dot file, you know, GitHub, right, or whatever it is. And, you know, I can just yank a section of the Nix code for their system configuration, and it just works, you know. So I'd highly recommend checking out the in fact, I will, I'll link the website in the chat here. Both the YouTube chat and the Twitch chat here. There we go. So that's Nix versus NixOS. So they have a little kind of thing here. It's also, there's another great thing about, which is that, you know, they say, like, this is one thing, try new tools without fear. Like, you don't have to install it and then worry about uninstalling it later if it's just a temporary package or whatever, especially if it's like a C dependency or whatever. So that's what that is. And it's all based on the Nix language. And Nixpkgs provides a whole bunch of packages that you would use for that. Here we go. I should have just kept reading, because this is a great little Nix expression. Nix expression for the subversion package. It shows how assertions can be used. Yes. So we see a weird operator. I don't fully understand this operator yet. It's a logical operator. But you can see basically the whole idea here. And when and where it can be used, because that can be confusing, like where can I use this, where is this legal. So yes, the points of interest, we have the assertions here. With expressions, the much advertised, what I kept referring to with, this is, it basically brings you have, essentially, you know, before an expression, you'll have with package set expression, and then it brings those into scope. I should be absolutely clear here that this does not, let's say A equals A, B equals B, C equals C. Let's see here. What would I say? Like, with A, or B equals with A, we'll say, D equals D. Like, unlike, you know, it doesn't work like inherit, right? It's not bringing those things into scope. Not by default, anyways. So it's just D here, but I can do like A equals, you know, or B equals C or whatever, because C now, C is in scope, because I just took all the attributes in A with and just chuck them into the scope as variables. And, you know, with this, I can also, you know, inherit, you know, B, C. And that'll give us that. So I can inherit similar to how I can, like that, you know, I can do this. If I'm aiming to bring things into scope, that's one thing. That's probably why I would do. But with is so that you don't pull them in, and it also works in any expression, including lists, which is super useful if you have, you know, system configuration or whatever, and you're defining what packages you want a user to be able to have just installed by default. and so you can use a with expression before a list, and you can just list the the packages in Nixpkgs that you want to have without having to type Nixpkgs dot Nixpkgs dot Nixpkgs dot Nixpkgs dot blah 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 blah, right? So yes, you can. It's just you can put a arbitrary expression in there. Sorry, what b equals with a means. That's a good question. So b equals is basically the rest of the line is an expression. This is Nix REPL. So just you can just define similar to a let statement. You can just define variables like that, which is normally not possible within the within it. So b equals, then this is an expression with a. We start the expression with a, or this is part of the expression to basically similar to a b equals let a equals 1 in nope, there we go. Or I could inherit a. That works too. It's similar to that. That just brings sort of like a let binding that just binds all of the attributes in this attribute set, and just brings them into scope. With a and semicolon, yeah, with expression, with like with like this. Oop, right. I keep forgetting that. With a returns what value. With a and semicolon, yep, that's, you end the expression with the width statement with a semicolon. With a, since a, well, I can't remember what was a up here. Let me check the last value of a. When we had this, a was a variable that we defined. Again, this is Nix REPL, so we can just define variables and use them later. We had earlier defined a to be this attribute set, b equals b, c equals c. So when we used with a, we were using this because it was a variable in scope. Again, we're going to get to actual like expressions here. I'm just using the REPL to demonstrate basic language concepts so far. So we have with expressions, here it is with a let in, so we can use something else. Again, this is, usually you're using with, and then, an identifier of something, or getting an attribute set somehow, and you're not defining it manually. Like for example, let me pull up my, oops. Let me pull this up here. I think this is good. Let me give you a big example here. So this is my system configuration here. So as you can see here, we have several with with packages, and this is basically prevents me, or this, it's not an expression by itself. Oh, semicolon. With a, yeah, Nix loves to just do weird stuff like that. Yeah, I can see your confusion now. I definitely see that. The semicolon confuses. Yeah, that makes sense. It's a little bit strange. But yeah, this is only, it's sort of like assertions. Assertions are very similar, right? Assertion represents, or it gets in a, where are you? Assertions, here we go. You know, ends with a semicolon, but doesn't end the total expression here, right? So this is a function. So it ends this expression, but the assert does not, you know, what actually comes out of this function, right? What it evaluates to is way down here, because these are just assertions on top of it, and they're not, if that makes sense, they're not affecting the actual the expression. They're just adding stuff on top of it. But yes, that is with expression. Comments, it's pretty simple. Block comments, you never see those. Yep, they can't be nested. Very common. Consider escaping nested comments and unescaping them in post-process. Okay. Scoping rules. This is. Yep. I haven't really read this part, but it's pretty simple. Primary scope, secondary scope. So yeah, so these will always override with. That's pretty important, and I actually use that in. I used to use it in my system configuration for defining custom packages until I remembered that overlays exist, which we'll get to. Oh my gosh. So those are the basic constructs. Now we get to string interpolation, which I didn't learn for quite a while, but it's very useful and very common, especially if you're writing derivations. So, you know, listen up, I guess. String interpolation is a language feature where, yes, string path or attribute name can contain, yep, it's an interpolated string, interpolated expressions. So it's basically, it's a lot like Bash, right? In Bash, you have, you know, in an expression, you'll have $sign variable or whatever, you know, in a string, or $sign, you know, parentheses. In Nix, there's always these curly brackets or curly braces or whatever you want to call them. I learned to call them curly brackets early on, although I know they're called braces. It's always this syntax, and this is useful if you're making a string that is going to go to Bash, because you can then just $sign a variable and not worry about Nix going, oh, for me, because, you know, it will do that if something intervenes, but it tries to be out of the way, right? So this is pretty self-explanatory. This doesn't have to be an identifier. This can be any arbitrary expression. Free type is getting instead. Wait, what? Oh, right, because a derivation returns its store path. I forgot about that. That's true. Yep. So we don't have to do this nonsense with string concatenation. So this is, oh dear, why are they not using the official syntax for multi-line strings? I don't know. In any case, though, you can see here expressions. They're not just then, else. There's actually a better way to do this using Nixpkgs. I'll get into that. Paths can be interpolated as well. They can just be directly interpolated like this, which is nice. Attribute names, yep, pretty sweet. And we can select them using interpolation, which is what the switch statement that I showed earlier, how that works. Must evaluate to one of the followings, or one of the following attribute sets. Generally, outpath, this gets a little bit funky, but this is, most derivations, especially in Nixpkgs, are going to have this outpath attribute, so you can just pass them in. Generally, though, any old attribute set is not going to, it's not going to work. You can't pass it. A string interpolates to itself, yes. Whether it's a standard string or a multi-line string, which we'll get to. A path in interpolated expression is yes. What is interpolation? Good question. Interpolation is basically this process where you have something like an attribute set, you have something like a string, something like a path, and you basically inject, string interpolation is the process of evaluating such a string or a path with kind of injected other things that are turned into strings, or path segments, or what have you. That is interpolation. Typecasting, sort of, yes. We can see here what an expression that is interpolated must evaluate to one of the following. So those are the things. Type shifting, yeah, basically, only types that can be coerced, casted, whatever you want to call it, to one of these, or only evaluation, or yes, only expressions that evaluate to one of these types, which can be casted to a string, can be interpolated, or can be pasted into a string or a path or an attribute name. So interpolated expression, excuse me, a path and interpolate, yep, and the resulting string is the store path of the newly created store object. So that's important to know, because if you want to avoid copying stuff into the store, which you may want to do, because that can be expensive, you may not want to do that. You may want to avoid that if possible, and just be aware that that's what's going to happen, is that the path won't automatically get copied into the Nix store, but if the path gets if the path is interpolated, then it will be whatever the path points to will be copied into the Nix store. Of its first output. Yup. We'll get to the multiple outputs and stuff like that later. Yep, to string out path. Okay, yes, that's string interpolation. I wonder if we should kind of play around with this to kind of get it, kind of figure this out here, or not figure it out, but kind of practice with it. What would be a good idea here? Touch, test. Oops. Oh, right. There we go. See, it's evaluating to the system path, but what if I interpolate that? Will it still do that? Nope, it doesn't. As you can see, it gets the file or directory and everything in it gets copied into the Nix store. Now that's garbage. So just be aware of that will happen if you do that for large directories. And it can be a little bit tricky. So be careful of if you're using a if you're putting a path inside a a Nix like if you're making a derivation and you have a bash section of it, and you want to refer to local directories, generally you're going to want to refer to them within the string with the local directory. Everything is local to the sandbox and not try and use paths for everything. And we'll get into that when creating that. So if you look up paths, this is if you're wondering basically why the why this works. It's not a path. There are certain things that are built in. Basically, I don't fully understand this, but it's sort of like in C how you'll have like, versus, include. Like that, or what was it? There we go. That's C. But now I have, so it's sort of like that, but for Nix. As you can see now, though, I do have, oh, right, so here we go. Oh, right, because I tried to evaluate PKGs, like a dum-dum. Yep. It's not the only part of yep, so it doesn't, you can't just evaluate the whole of Nixpkgs, by the way. drink of water. String context. Yep. I don't think we need to go into this right now. Parasequence, yes. Attach the string, concatenation string, okay. Oh, right, because it's lazy, I forgot. Because it's lazy, it has to capture the context in order to evaluate the laziness. Yeah, I don't think we really need to go into this too much. So that's our, excuse me. Is the Nix language similar to other programming languages like C++ or Python? Because I'm just getting started. Some people recommend Python, others C++, others C, so it could be very useful to learn a programming language and use something similar, Nix, to learn a system that is offering a lot of unique benefits to developers, as I understood. Yeah, I mean, are you looking to learn programming, or are you looking to learn Nix? Oh, Mr. Potatoes 26 on Twitch says hi. Hello. Because Nix is a domain. It's pretty easy to learn in my opinion, but it's a domain specific language. It is specific to the Nix package manager, and NixOS. But I think it is easy. It's a functional language, and functional languages are kind of rare. I will say that. Oh, I see. Okay. Some people recommend Python, others C++, others C, so it could be useful to learn a programming language if they're supposed to flow together and use something similar. Yeah, so, I mean, Nix is pretty complicated. My hope is to kind of demystify it and kind of make it easier, because I think it has an enormous amount of potential and possibility, because it does provide a lot of benefits. The deterministic, constant, how do you say, like that sort of stuff, builds is very, very useful in my experience. But if you're looking to learn like a language to use, like as a programmer, then like unless unless your goal is to learn Nix itself, Nix is a domain specific language. If you like the style of Nix and kind of its functional paradigm, I'd highly recommend looking at learning something like Haskell. Haskell is pretty sweet. Bootstrapple. It's bootstrappable. Yeah, don't know entirely what that's referring to, but Nixpkgs really tries to be bootstrappable. Tries to have a way to bootstrap itself. Operators, then we can get to derivations as a first language. Yeah, that's what I'm wondering. So we have attribute selection. I don't think we really need. This is mostly operator precedence. There is a learn basketball for greater good. Okay, there are a couple of notable things here. Has attribute. We have string and path concatenation. Update. So let's look at some of these. We understand comparison. We understand some of these logical expressions. I think we should look at has attribute. And what was it? Where were you? Update. So let's say A equals 1, B equals 2. So if A is now an attribute set, we can check if A has a certain attribute with that question mark operator that also kind of applied to default arguments. It's important to note that this only applies to identify. Wait, what? Used to only apply to identifiers. Oops. That's interesting. I could have sworn. Okay, never mind then. You can use that with a you can use it with strings. I probably should have looked at this here. Denoted by attribute path, the result is, okay, yeah. C also has attr. Let me see here, because this used to be that as an attribute. This is a dynamic version, since S is an expression rather than an identifier. That's interesting, because this seems to work with expressions perfectly fine. Haskell, basilisk, basilisk, or Pascal. Oh, I thought you said basketball. Oh my gosh, I need to increase the font size here. I'm not dyslexic, but I have a hard time reading text. I see. What language would you choose if you had to relearn programming? If I had to relearn programming, personally, I would start with, for me specifically, I would learn C. C is not a great choice for everyone. C is not for everyone. Because it's complicated, because it's tricky, because it's very low level. A lot of people recommend that you start with Python or Java. I'm going to be honest, I really don't like Java. Java is such a pure object-oriented language. And this is the problem with Haskell too. If you like Java, if you like Haskell, good for you, but the skills aren't super transferable. Whereas if you chose C#, which is a lot like Java, I feel like that's a little bit easier. Smalltalk, what I'm learning right now. Smalltalk, I don't know much about it, but I've heard that it's pretty good and pretty easy. It's very rare that you see stuff written in Smalltalk anymore. I would have learned C though, because a lot of other languages like to obscure, like I really like to know about like how does the computer work? You know what I mean? Like, well, like what's going on under the hood? I really want to know that stuff. I gotta know. And it's the first thing I always ask about, language, programming language. And C doesn't hide any of that. Whereas, like, if you go to Java, or Python especially, or Smalltalk, everything is just super abstracted away. Everything is, they try and, like, make things. I mean, it is a programming language. It is um, glow glowlerless uh, toolkit um, for what small talk. Um, Glowlerless. Yeah, but it's like those languages will try and obscure that stuff, whereas C puts it front and center. Like with C, you're working close to the hardware, you're working with the hardware, you're working um 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 what else was I gonna say? I mean it really glamorous, nice. You'll have to look it up. But essentially that's my spiel about programming languages. Java I feel is kind of a stuck in. I mean it's useful, but it's just you can do better. In my opinion, I can see why people choose it, but it's so restrictive. And now that there are other options available, people are like there are more people starting new. You know, one of the oldest languages now is C. Um, and I see more projects being started in C than I do in Java. Maybe that's just my perspective, but I feel like I don't need hardware. I need subclass of arrayed collection, which is an object. Um, yeah, maybe, yeah. I get a little bit, I'm finicky about, I obsess about, um, I, um, I get obsessive about the efficiency of my code. I just want to use what I need. Um, and so, um, you know, like I don't have a, I'm not saying that like other languages don't have that. This is why I love Rust, because it has the abstraction and it has that control. C++ is similar. You know, it's not similar to Rust, but it's like similar in that you have like a higher level interface and a lot of control over stuff. And you're not doing this wild inefficiency with that you get with Python, that you get with Smalltalk, that you get with um, Java, that can make it easier to work with and easier to learn, but you don't learn how computers work by studying Java. Even though every college will teach you in Java. They want you to know Java, but um, which kind of drives me crazy because I feel like Java is just falling out of the floor. But um, maybe I'm wrong though. Even like, you know, I like that I found a university personally that I think shows a lot of promise. They're like very future thinking, future oriented and such, that they're really obsessed with we gotta teach the new things, like what's going on right now. And you know, currently there are a lot of jobs that look to be opening in embedded, so they're really focusing on that, which I appreciate. Um, as opposed to the other NPC universities that just Java, 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 Java. Um, so anyway, so we have the next important operator is the update operator, which is applied to attribute sets. You'll see this a lot, usually to add attributes to another attribute set. So for example, you know, I did this. So I defined, you know, A is way up here, right? We have A is this. Then I defined B is this. And if I use the update operator, A, update B, you'll see that there's kind of the effect of mushing them together, but that's not entirely true. Often this is how it's used, but it's not always. And it's it is different. And you'll see here, if I, instead of updating A with B and adding B's stuff, now I'll add B equals B and C equals C. You can see here that the update operator does more. It does more than just add the stuff, because if there are already attributes here, you know, A has B. It already has B equals 2, but we define B equals string B here, and you can see here that's replacing the B in A. So that's why it's called the update operator, because it updates the former, you know, the left hand side with the attributes from the right hand side. So that's the point of the update operator. Although it is most commonly used for adding attributes sets together, which is its primary. I think it's the thing that's most useful for, in my opinion. It is useful for truly updating, but I feel like it's most used for adding, for combining. But just be aware that it has this behavior. That's not purely adding. It's also updating. So we have arithmetic here, concatenation. So now let's, and we have, similar to many other languages, the C-like languages, you have these sorts of Boolean operations. Now we talk about an important part of the Nix language that is often ill understood. Often when people learn about derivations, they'll just learn about how to use MK derivation, or make derivation, and in the standard environment, which is great. We'll learn about that too, because it's super useful. But it's but that's not what a derivation is, because a derivation is a special kind of attribute set baked into the Nix language. So what is it? The most important built-in function, according to them, I beg to differ, because no one uses it. Merging, yes, it merges them and overrides. Exactly, left merge. Exactly. Which is used to describe a single derivation, a specification for running an executable on precisely defined input files to repeatedly produce output files at uniquely determined file system paths. It takes as input an attribute set, the attributes of which specify the inputs to the process. It outputs an attribute set and produces a store derivation as a side effect of the evaluation. Side effects in a functional language? I don't think so. No, apparently though. So you have, and keep in mind though, we're looking at pay attention here to what a derivation is at its most core. We don't care about this derivation function, because basically no one uses it. I want to emphasize that when you're designing a package, 99.9% of the time, you're going to be using make derivation, MK derivation, from the standard environment. You're not going to be using derivation, unless there's nothing useful to MK derivation for you. So what are the components of derivations? We have the name, required, is add to the store path of the, okay, yes, as well as the output paths. here we have a little example. A hash, hello.derivation, DRV. System, this is optional. The system type on which the builder executable is meant to be run. A necessary condition for Nix build derivations locally is the system attribute matches the current system configuration option. It can automatically build on other platforms by forwarding build requests to other machines, which I haven't seen before, but oh well. I don't know entirely what this means, but yes, on specific machine type, yep, builder, here we go. This is the executable that will be run. Copy a local file is Nix store for use as the builder executable. There you go. Here's that. Use a file, muck derivation, make derivation. Yeah, I'll type it in the chat here. Oops. There you go. That's often used. I'm gonna fast forward a little bit here. Use a file from another derivation in the builder. Okay, so we're just focusing on what this is. These arguments aren't super useful. Outputs, here we go. This is kind of useful. This is a little bit important to know. Symbolic outputs of the derivation. Each output name is passed to the builder executable as an environment variable with its value set to the corresponding store path, blah, 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 blah. By default, yep. So this is a core concept that applies to make derivation too. The kind of the outs, multiple outputs, we'll see that eventually. This allows the associated store objects and their closures to be copied or garbage collected separately. Ooh, I nearly knocked my phone off. Yep. Or copied or garbage collected separately. So here we go. So we have an example here. I'm just kind of skimming these to see if there's anything that they say to remind me that's important. Lua Sunrise asks on Twitch, for what do you learn Nix? I don't know if you have the earlier chat message. Let's see here, there we go, of the NixOS website. It's Nix's domain-specific language designed for usage with the Nix package manager or with NixOS, essentially. The builder would typically go something like that. Yep. Okay. For autoconf style package. Yep. Let's see here. Builder execution. I don't think this is super. A temporary directory is created under the directory specified by tempter, default TMP, where the builds will take place. So this also applies to MK derivation, by the way. Where the build, the environment is cleared and set to the derivation attributes. Yes. In addition, the following variables are set. So these are useful. So basically, my main point here is that MK in make derivation, you can use the temperature environment variable. Which OS is it? NixOS. Here, I wonder if is the chat message gone? I think it might be here. Copy link. It's so Nix is a package manager that you can install to oh my gosh. It's a package manager you can install to Linux, to Nix Home Manager 2, and Flakes, says someone on YouTube. Yes, it's a package manager for Linux, for Mac OS, for you can do it on WSL. There's also NixOS, which is an operating system. No way I'm using this on Mac OS. Lol. I mean, you can, and it's pretty cool in my opinion. Someone on YouTube says, I think your brain is begging for some rest. I don't know. I know I sound tired. I'm always kind of tired. This looks scary and too messy. It is scary. It's a bit it is a bit messy. If you're not, the whole point of this is for people who are either configuring stuff for homebrew install is way too convenient for me. I can do this. Like that, and then I can let's see here. There we go. This is horrific. Don't they all, says Qzump. I don't know what that, you mean all the package managers? Yeah, they're, wait, how'd you make this colors? That's lolcat. I piped LSLA into lolcat, which I installed using this. And this is a temporary installation, by the way. It dropped me into a shell where that's used, and then I exit, and now, guess what? It's gone. It's now I can garbage collect that package, and it will Winix undose. Yes, if you use WSL. Yeah, so now it's kind of, so it's you can bring in, instead of like, that's what I like over Homebrew, is that Homebrew you bring in packages, and those just stay on your system, like you need to bring it in for something, whereas this, you bring in them temporarily, or you need to build a certain thing, so you use a derivation and build it there, and automatically use and discards those packages. Now, to be fair, you have to garbage collect them once you're done, but it'll prune all the packages that are not actively being installed or used. Man, I'm so proud of you. You can do things that require so much knowledge. Sad that I can only do the simple stuff. Oh, I mean, you get you get to where I'm at. It requires experience. It's all about experience. Yeah, when I check out project and see it has flake, I know I can try it out. It works like magic. Yeah, yeah, that's another really cool thing is that, like, generally you don't need to worry about like reproducibility, because all the building happens in a sandbox. If you define something as a derivation, then the building happens in a sandbox, and it will. What about Arch? How do you compare it to Nix? Um, I mean, if we're talking Arch, then I'm assuming you're going to talk, like, we're talking about like Arch's package manager, Pac-Man, versus as opposed to Nix, the package manager. Nix is easier if you use provided config options. That's true. That's another thing, is you can just like copy someone else's configuration files and they just work. Doesn't break as much. Yep. Plumbing it though is a pain, because you got to know this stuff. Again, I'm writing this for like derivation authors, or not writing this, but making this tutorial for those making a package. Pac-Man, it's really nice. I think it's the second best package manager available, to my knowledge. Like, it's, you can also kind of garbage collect. You have a series of packages that you've explicitly installed, but that's still kind of like my main complaint with it compared to Nix is, like, imagine you're like building something and you're just, you need certain dependencies, so you bring them in, but then it's like it's easy to get lost and like lose track of, like, okay, what dependencies am I using for what though? So it's hard to remember to go in and garbage collect everything. Whereas with Nix, if it's not actively being used, it can be easily identified as garbage. It's discarded when it's not used. Well, it sticks around. So if you need to rebuild it or redo it or re-pull it into the shell, then you can do that. So what do you think about Windows then compared to Nix? I don't know much about how. I know Windows has some like C++ dependency management, but I know basically nothing about it. Derivation Magnus. Windows, I don't like Windows as an operating system. I'm sorry if you like Windows. I've had this argument before, and I don't. Yeah, I don't know. This is in a project I work on. There's a development Discord, and so you don't play games dual boot. Exactly, that's what I do. Is for the yeah VM. That's what I do, is I dual boot. Is because for the, because Proton can run a lot, but there are a lot of games that have sketchy DRM attached to them, and I don't like that. Lutris, yeah, that's another option. So I use, I do sometimes do gaming on this, on the Twitch channel, which is mostly on Windows, because I have my development laptop, and I have a very old gaming rig that can barely, it's held up remarkably well. It's over 8 years old now. And it's but it's still going strong because I take good care of it although I really need to replace the thermal paste. That's one thing I'm not taking good care of it. But I like to do that because it sandboxes the stupid DRM. It's super sketchy. Some games I just are so sketchy that I just refuse to play point blank. You know, anything with was it like was it the new Valorant anti-cheat is just so sus. It's so incredibly sus. I will not do it. Anyways, yeah, so I'm digging into the heart of it here. Maybe I should be going for a more top-down approach for the tutorial here. This is probably not. All you need to know from this is that derivations are things to build. GeForce Mabini hipster. What's? I don't understand. GFN. Okay, there we go. This is probably not necessary to know about. You know, derivations are just, they're things that are built in the in the sandbox, and in a sandbox environment, and they have, you know, their environment variables are configured so that they work there. That's the idea. That's the general idea. I think that we've built-in constants and built-in functions here for Nix, but I think this is I think this is basically everything for this part. There's a lot of, we can go through this later as needed, but there's a lot of stuff here to take note of. So let's see here. Let's RM test. There we go. Let's take a look at importing. Ask a friend to, what? I don't understand that. Let's see here. Okay, let's just make a file here. Let's make a, so as we'll see here, Nix files are just, they're basically just expressions. So we have import, basically imports a file via from a path. An import basically just evaluates the file as a Nix expression and returns the result, essentially. So that's what that is. So that's kind of what is that's kind of what's happening when when you import the angled brackets, or whatever you want to call them. These are this is kind of like you would see in C or C++, where your kind of system files are referenced using these. But it's basically the same idea here, right? Where pkgs is a it's a function, and when you use that, you see this so much, but you don't really notice that this is you know, this Nixpkgs, it's a built-in file, and when you import it, it evaluates to a function, and that function we're just calling it here with no arguments. That's basically what it is. That's all it is, really. You see that a lot when you're like making a shell or whatever. Can you import vars into lexical scope? Let me see here. Let me close that. Can you import vars into lexical scope? Not really. You'd have to, no, because the file is just an expression. It just evaluates to an expression, so you'd have to use like a let binding, to grab that, to basically, you know, store the evaluated result of the file. That's the import. So that's the basics of the Nix language. I might leave it off here for the day, I'm thinking. That's basically the Nix language. And I'll have to figure out how to like make this more concise and stuff. Because this has been a mess and probably not very helpful at all. That's why I like GUIX has an actual module system. Yeah, I'm not super familiar with GUIX. I've heard of it though. Transactional package manager. That is Scheme. Interesting. Declarative system configuration. Oh, nice. Okay, so this is a lot like NixOS is what's promising here. How do you get make derivation though? I might wrap it up for, I'll have to look into GUIX for today probably. How do you get standard library functions? That's where Nixpacket in lexical scope. That's where Nixpkgs comes in, right? If you do this, then packages is in. We've brought the packages attribute set into scope, or we've brought, yeah, because we got this function, and then we evaluated it, and now we have packages, which we can then use it, and you can, from then you can, you know, inherit from PKG's, you know, stdnv dot make derivation. You know, that's kind of how you would do that. I think though for today I might wrap it up and we'll dig into Nixpkgs hopefully tomorrow. Because most of, like, that's, I covered, like, except for the built-in functions, I covered basically all of the Nix language itself. Everything else is the standard library, Nixpkgs, which is also where all the standard packages, like lolcat, are at. That's where they're all stored, and such. Alright, so I might just, what should I do here? Probably just end the stream here, and then we'll come back another day, hopefully tomorrow. We'll see. Alright, because I'm getting a little bit fatigued here. Although I am excited to get to Nixpkgs because I've been learning a lot about it and like the internals, and I can walk walk you through that and kind of how that works inside. Yeah. Alright. See you later. Yeah, no problem. No problem.